So here we have part 3 of exercise 3.9, and it looks like we're going to stretch into at least one more part after this. So let's go ahead and take a look at what these 4 problems consist of. 33 is going to use the log base A rule, which let's quickly review. Y equals log base A of u, and let's do it as a chain rule. The derivative, and I don't know this one quite as well because it's not used as often. Just like natural log, it should be 1 over u times 1 over the natural log of a. Or you could have just written it as 1 over u ln a. Times, of course, chain rule, du dx. So that is the derivative. So here we have a log base 2, and we also have a chain rule. So that means the derivative, we'll do the log part first. So the derivative of logarithm is 1 over the thing you're taking the logarithm of. So 1 over u, and then times, and we'll go ahead and put it right under this fraction, the natural log of 2. So all of that is the derivative of log base 2 of anything. And then we need to multiply by the derivative of 3x plus 1, which is simply 3. So let's clean this up a little bit. Simply giving me 3 over, we'll put the constant in the front, 3x plus 1. And that should be it. So then we get to 36, and I have a choice. I can either do this as a quotient rule, or I can rewrite the problem, which I usually do, as log base 2 of x all to the negative 1 power. So let's try that and see how it works out. So now I've got a chain rule dictating what I do first, which would mean I'd get negative 1 times log base 2, I'm probably writing too big, of x to the negative 2 power. So that's your outer function, negative 1, no change to the negative 2, times, now the derivative of logarithm base 2 would simply be 1 over x, natural log of 2, and since it's just x inside of logarithm, there's no chain rule, and so we're done. So, you know what? I don't even think we're going to mess with it. Let's just leave it alone. The negative 2 power would mean this comes down to the squared, the whole thing's negative. Yeah, it's close enough. I'm hoping I don't still sound nasally, but I didn't watch the second video before I did this one, and I assume I probably am. So we'll just go with it. Maybe that's just how I sound. So we have one more to do here. Log base 10, so we're still going to follow the same rule. So it's 1 over, we have a chain rule, so the logarithm's on the outside. So the derivative of log base 10 of anything is 1 over that thing times the natural log of the base. So that's all of the outside function. And now I take the derivative of the inside function, and the derivative of e to the x is e to the x, which does simplify nicely because I have e to the x in the numerator, e to the x in the denominator. It looks like the answer is simply 1 over the natural log of 10, which is interesting. You might notice that this has no variable in it, which means it's a constant. And if your slope function is a constant, that means the thing you took the derivative of must be linear. So what that means is y equals log base 10 of e to the x, even though it may not look linear, is linear. You can actually see that it's linear if you rewrite it using rule 3 of logarithms. And I could rewrite the problem here as y equals, bring the x down, x times log base 10 of e. And it may not look like it, but log base 10 of e is just a constant of some kind. It's just a number. So in a sense, we have y equals mx, and the y-intercept would be 0. And the m is this complicated slope, apparently 1 over natural log of 10. Anyway, so that's our answer. So number 42, it asks us to find the equation of the line that's normal to the graph and goes through the origin. So going through the origin is nice because that means we already know my y-intercept is going to be 0. So the only thing left is to find the slope. And hopefully by now we know that the derivative gives us our slopes. So we take the derivative. I have a product rule. The derivative of x is 1 times e to the x plus x, and the derivative of e to the x is e to the x. So this is my derivative, and I want to evaluate it at x equals 0, giving me e to the 0 plus 0 times e to the 0. And 0 times anything is 0, so we're really left with e to the 0, which hopefully we realize is 1. So the derivative is 1. That means the slope of the tangent line is 1, but I want the normal line, so the slope I'm interested in is going to be the negative reciprocal, which would simply be negative 1. So I've got a slope of negative 1 and the point 0, 0, which is my y-intercept. So the answer should simply be y equals negative x. And that concludes part 3.